Welcome back. In the last session we have discussed the anatomy of LSTM node. And today we are going to look how the weights, how the number of parameters is computed. So let's have a look. Here we have defined the LSTM layers with 10 nodes. So let's execute. Okay, and then we see here in the last column we see the number of parameters, and we see that for LSTM, for the first LSTM layer we have 480 parameters, and for the second LSTM layer we have even more, 840. So let's see if we increase the number of nodes to 20, what is going on. So now we have even more. So the first LSTM layer has 1760 parameters. The second LSTM layer has 3280 parameters. So where all those figures are coming from? So let's have a look. What we have here is that each LSTM node has 3 gates. So we have input gate, we have forget gate, and we have output gate. We have also said that the cell state is its memory. Then we have also defined the hidden state. Hidden state is equivalent to the cell output, meaning LSTM hidden state size is the same as number of nodes or neurons which we have defined, which we have to define, and this is the same as output size. So let's have a look again. So here, let's say again 10. This LSTM layer has 10 nodes, so the output size is equal to 10. It has 1 cell state, 3 gates, and 10 output nodes. What is about input nodes? Let us have a look and compute for the first LSTM layer the number of parameters. But first, here is the formula how it's computed. So we have the weights for input size plus weights of output size plus 1 bias variable. Input plus output plus bias variable. And this is all along the output size vector multiplied with 3 gates plus cell state, so 4. So 4 multiplied LSTM output size multiplied with some input size plus output size plus 1 bias variable. So let us compute and see. It's actually pretty simple if you have tried it by yourself. So first of all, we are taking the first LSTM layer. This is the first LSTM layer. First LSTM layer. It has output size is equal to 10, or this is the same as hidden state size. It has, how many inputs does it have? So, well, we have here above that we have input layer, and this input layer has dimension of 1. So the output of this input layer is also 1. Therefore, we are computing it like this. So 3 gates plus cell state is 4. Multiplied with output size, which is equal number of nodes, is 10. Multiplied with the sum, and then we have input size of the first layer is 1. So it's receiving inputs from the first input layer, which has dimension of 1. Output size again is 10 and 1 bias variable. If we compute this, we're getting 480. Let's see. Yes, we have 480. Now let us have a look at the second layer. Second layer has again 3 gates plus cell state 4. Multiplied with output size is again 10, but input size is not 1 anymore, but 10. Why? Because it's receiving the inputs from the first LSTM layer in the dimension of 10. It has 10 nodes. The output dimension is 10, and the output dimension is of the first layer is the input dimension of the second LSTM layer. So we have the input size is 10, the output size is again 10, and 1 bias variable. We are executing this and getting 840. Let us see. Yes, correct, 840. So with this, enjoy our sessions and see you next time. Bye bye.